Welcome to the 6 Classes webinar series. Over the next weeks, we will learn the chemistry of 6 families or classes that contain a majority of the harmful chemicals commonly found in consumer products. Chemicals in these classes are associated with long-term health problems, including neurological and reproductive impairments, hormonal and immune problems, and cancer. By reducing the use of these 6 classes in everyday products, we can reduce their adverse impacts on us and on our environment. I first became concerned about harmful chemicals in consumer products back in the 70s when I learned that a flame retardant called brominated tris was in children's sleepwear and was up to 10% of the weight of the pajama fabric. Could tris be harming the children? We found that when a little girl wore tris-treated PJs for just one night, we could measure tris breakdown products in her urine. Then we tested tris and learned that it changed DNA and it was likely to cause cancer. So we wrote a paper in Science magazine stating that the main flame retardant in children's pajamas could be cancer-causing and should not be used. Brominated tris was banned from children's pajamas only 3 months later. Some of you may remember, although it was 40 years ago. However, when a chemical is removed from use, the tendency is to substitute a similar chemical. So when brominated tris was banned, the substitute was chlorinated tris, which was also found to change DNA and be likely to cause cancer. Chlorinated tris similarly was removed from kids' pajamas. This is a common pattern. When a chemical is banned, the replacement chemical is very similar and can cause similar problems. The movement from a harmful chemical to a chemical cousin has been termed a regrettable substitution or a toxic whack-a-mole. You have perhaps also heard of the TSCA problem, that we have 80,000 industrial chemicals in use and very little information about their health effects. A couple of years ago, 25 leaders in science, business, and nonprofits came together to try to solve the toxic chemical problem. We identified 6 classes of chemicals which contain a large proportion of the known harmful chemicals that are used at high levels in consumer products and that are not yet adequately regulated. For each of these 6 classes, there are thousands of scientific papers documenting harm. The chemicals can migrate continually from products into dust and air, and they end up in us, our children, and the environment. Many are endocrine disruptors. They're associated with long-term adverse health impacts. In our classes, we didn't include foods, drugs, and pesticides because these 3 kinds of chemicals are regulated. Now, instead of worrying about 80,000 untested chemicals, we can focus on 6 classes responsible for much of the harm. If you go to slide 2, you'll see the periodic table of the elements. To the right, there's a blue circle around the halogens. You can see fluorine, bromine, and chlorine. The bond between carbon and these halogens are among the strongest in nature. That means the bonds are not easily broken by bacteria or by our metabolism. These sorts of molecules with halogen-carbon bonds will stay in our bodies and the environment for a very long time, in some cases thousands of years, and have the potential to eventually cause harm. On slide number 3, we see the 6 classes. The top 3 classes are the halogens. The first, highly fluorinated stain and water repellents like Scotchgard and Gore-Tex. The second, chlorinated antimicrobials, that's triclosan and triclocarban. Third, the flame retardants, brominated, chlorinated, and phosphate. All these halogenated chemicals are often toxic, fat-loving, or lipophilic, and they tend to be resistant to breaking down. Indeed, all 22 chemicals that have so far been globally banned as persistent organic pollutants by the 150 countries in the Stockholm Convention are organohalogens in these 3 classes. These sorts of molecules with carbon bonded to fluorine, chlorine, and bromine aren't naturally found in any mammals, so our biological systems don't recognize them. They tend to enter our bodies and to stay for a very long time. The fourth class is endocrine-disrupting plasticizers like bisphenols and phthalates. Then we have organic solvents like benzene, methylene chloride, xylene, and the final class is metals, lead, mercury, chromium, cadmium, and arsenic. The good news is we've known for a long time about the harm from these 6 classes of chemicals, and their use is indeed going down. In our series, after the 6 lectures on the classes, we'll have a 7th lecture, Do We Need It? Asking, do we really need to use these chemicals given their potential for harm? If a mom whose baby is crawling on a stain-repellent treated carpet knew that harmful chemicals could end up in her baby and stay a long time, would she choose to have her carpet treated with stain repellents? Is it worth it? Our final lecture will discuss if we decide we do need a function such as stain repellency, it's time to put resources and energy into finding substitutes through green chemistry to reduce harm. During these short webinars, we will learn about the 6 harmful classes of chemicals, ask if we really need them, and talk about green chemistry. Then consumers can make purchasing decisions to reduce the use of the 6 classes, and so can large purchasers, manufacturers, and retailers. I want to conclude by saying, as a chemist, I love learning about the order and beauty of molecules and sharing that with others. I believe many chemicals make our world a better place, but there are bad actors that can harm our health. Many of these with high levels of human exposure are in the 6 classes. By reducing the use of the chemicals in these classes, we can have a healthier world. So let's begin now.